data in the accompanying table, rate of return for the stock compared to the rate of return of the index. In other words, we're thinking about investing, putting our money into this stock versus putting our money just in general. We want to know if this stock is doing better or not. So click on the icon. So in April 2007, the stock market as a whole went up 4-point-something%. Our stock itself didn't do quite as good, went up only 3-point-something. In May, the whole stock market went up 3-point-something, but this particular company did better. So some months it does better, some months it does worse. So let's open it up in StatCrunch. Okay, I'm rearranging this a little bit. So treating the rate of return as the X. So rate of return of the index is X. So let's do a regression. Regression, simple linear. Rate of return of the index is X. So my stat lab was nice. It even wrote that in for us. Company is Y. Compute. Okay, and here is the regression equation. It's kind of long because the name of the names of the variables are pretty long. If we look at the chart, so this you can see is not as strong of a correlation. The points are scattered up and down. It's not a perfectly straight line, but it looks like there could be a pattern. There could be a pattern that the two variables, X and Y, are correlated. Okay, so the estimate of beta 0, which is the intercept, to 4 decimals, 1.2210. Oh, I forgot to show you the homework coverage. You have to remember that. You check answer, estimate of the slope. So we're just reading these off of the StatCrunch output. 4 decimals, 7609. 7609. So now we've computed the regression line, slope and intercept. Okay, test whether there is a linear relationship or not. Alpha equals 10. Null and alternative. Linear relationship, okay, so I'm going to write a little bit right now. So we have y equals, so I'll use the book's terminology. Remember, the 1 is for the first x, the beta 2 is for the second x. So this is the slope, and we want to test if the slope is 0 or not. Remember, the null hypothesis is always equals. We saw that with one proportion. We saw that for one mean, two proportions, two means. Same thing here. The null hypothesis always has an equal sign. So the null hypothesis is that beta 1 is equal to 0. So null hypothesis is beta 1 equals 0. This says whether a linear relation exists. It doesn't say test whether a positive relation exists or test whether a negative relation exists. It says a relation. So that's a two-tailed test. We're just seeing if the slope is not 0 or not. We're seeing if the slope is 0 or not 0. Determine the p-value. Okay, let me look. Where is the Well, that's easy enough, right? All we have to do is to look at the p-value for the slope 0.263. I'd mentioned the analysis of variance. You see the p-value for the analysis of variance is exactly the same. So we don't really have to look at that for simple linear regression. So 0.26 is the p-value. And you know what the next question is. P-value 0.26, the alpha was 0.10. So is this going to be a reject or do not reject? P equals 0.26, alpha equals 0.10. So P is low. So this is going to be a reject. Reject means there is a relationship. There is a significant linear relationship. Check our answer, and we reject. There is sufficient evidence. So this type of wording, reject when P is low, there is sufficient evidence, that's always true for hypothesis tests. It doesn't matter whether we're testing the slope or the intercept or proportion or two means or whatever. Rejecting the null hypothesis always means there's sufficient evidence for the alternative. So in week 4, we had a lot of new terms like reject and sufficient evidence, but we're using the same terminology every week since then. So it's reject, there is sufficient evidence to conclude that a linear relation exists. Okay, continue. Construct a 90% confidence interval for the slope. Well, if we want to do that in StatCrunch, we could click Options to go back to the previous screen. And I hadn't scrolled down, but just like all the other StatCrunch routines, there's a choice between hypothesis tests and confidence intervals, right? We saw that with one proportion, two proportions, one mean, two means, matched pairs, all of them had this choice. So we choose confidence intervals, and the problem is asking us for a 90% confidence interval. For those of you who are watching my videos, a bunch of the videos used the older version of StatCrunch where this was on a separate page, but hopefully that's not a big deal. Still the same things to check off. Compute. And now instead of a hypothesis test, we have confidence limits. So for the slope, right? For the slope, here's the lower bound, here's the upper bound. Now, are you surprised that 0 is not within the confidence interval? Well, you should not be surprised, right? Because there is a significant relationship, which means the slope is not 0. 0 is not a believable value, so the confidence interval here is entirely positive. Okay, so 4 decimals, 2, 3, 5, 3. It's the lower bound. And the upper bound is 1.2866. Okay, and now the last part. Mean rate if the rate of return is 3.25. So we could use StatCrunch actually can do this for us, or we could just use a calculator, or what I often do, I just use Excel. Okay, so it's equals, the slope is 1.22, the intercept is 1.221 plus 0.760945 times 3.25. I put in the slope and intercept from problem 4. Okay, so the intercept, is 1.221. The slope is 0.76, etc. So when I put all that in to 3 decimals, it's 3.694. So in other words, from this model, our prediction is if the total stock market goes up by 3.25%, then our particular company is predicted to do a little bit better than the total market. It's predicted to go up by 3.694.